So that is the last week already. And I'm glad we make it to the last week, giving you everything happened for this semester. And I'm going to use sharing the screen so that way I can write a little bit better. Hold on. Probably didn't share the video in this case. All right, I will go ahead and pull the screen in here.
Okay.
You can see the.
I was
Yeah,
like, what's
go
wrong
ahead.
with my camera?
Yeah. All right. So let's see. Can you see my screen now?
Yes, we can.
Yes.
Or I can.
Okay. All right. Okay. Good. Okay. So we're gonna start chapter 6, which is only 2 sections, and then we're gonna also go over the chapter 7. So text review. Actually, this is the best way to cover everything. In that case, so chapter 6 is a confidence interval. Chapter 7 is the hypothesis test. And sometimes people feel like these 2 chapters are kind of a little bit more challenging because it has a lot of new concept. But in my opinion, actually, some people, it also depends on, different people. Some people actually do pretty well in the past on this test. Maybe they spend a little bit more effort because it's the final or something, but not everyone do better in this final test, that's for sure. Okay, so I just want to give you a little bit heads up. It does has more new concepts, but once you understand the new concept, calculation actually is not, well, calculation is also based on the concept. So that's why it's very important that you understand the concept first, okay? Number 1, find the margin of error for the given value C. Now you have to know what is the C, what is the sigma, what is the N, right? C is a confidence label. And when we say C, confidence label, giving you 0.9 or 90%, this confidence label is in the middle of the bell curve, okay? That is a very important one. So the entire bell curve area is equal to 1, right? The total area for the bell curve, total area is 1, okay? And then we have a C in the middle is 0.9. So that means we have a 2 tails. We call this is a tails, 2 tail. Okay, so we have a 2 tail. We have a left tail. We call this one is a left tail. This side is a right tail, which we're gonna use in next chapter as well. So we have this 2 tail. You have a 1 minus 0.9, right? 1 minus 0.90, we're giving you 0.10, but we have to divide it by 2 because we have 2 tails in here. So 0.1 divided by 2, you got 0.05 on each tail, okay? And remember, when you read a table backward, we have to use the area to the left. Okay, so now we have this area to the left. This whole area to the left is 0.05. If I go to read this one, I will get a negative G-score. If I go to read from here all the way to the left, which is a little bit more complicated because now you have to add this area and this area, which is 0.95. If you use the 0.95 to read a table backward, you will get a positive G-score. And these 2 numbers will be the same. One is positive, one is negative, right? So knowing that, next time we can only just need to read 1 time of the G-score, and then we know the other one will be positive already. And I also show you we can use the calculator to read the table backward, make it much easier. All right, so let me show you one more time. Go to second vars, which is the distribution. Go to number 3, inverse norm. So when I hit the inverse norm, I type the 0.05 in. We'll get a G-score in here. And then if you run to 3 decimal point, so that is negative 1.645. This you will run up if you run to 3 decimal point. So that is the G-score in here. If I read the other side positive.
May I ask a question about that?
Yes.
I don't know why, but mine's not working.
I do second var's inverse norm.
Second vars, yeah. Then you have to go to number 3, inverse norm. Okay. And inverse norm, sometimes some calculator interface might be a little bit different. All right.
Yeah, it just pulls up the area and then you.
Yes, and you just type the area, leave the type the area to the left is 0.05, and then leave the rest as D4. Sigma will be 1, you know, so a mu will be 1, and leave the rest as D4. So,
okay, got it.
Yeah, good. Right, so yeah, calculator can be a little bit different. That's why you kind of get to know your own calculator a little bit better. Mine, this one is a little bit older version, so it didn't have a interface. So I just type a 0.05. Okay. All right. So that is the G-score in here. Once we find a G-score, we have a formula for the margin of error, right? We want to find the margin for the error. This is G sub C times sigma over square root of n. All right. This formula is in a formula sheet. If you do not know, we have formulas for this key formula. You have a key formulas for the which you can use for the test. All right, if you go to chapter 6, now you have a margin of error, right? C confidence interval, there's margin of the error is given by this one right here, okay? E is G sub C times sigma over square root of n, all right? So that is right there. And then we just plug it in. We're using the positive G-score, so this is 1.645 times sigma, this is giving to you 11.5, and then divided by square root of 120. All right, and we just put it in a calculator. We can use 1.645 times 11.5, and then divided by square root of 120. Okay, and then if we round to 2 decimal point, now we're giving you 1.73, right? This 2 decimal point, third digit is 6, so we need to round up. So now we're giving you 1.73. All right, so that is how we calculate the margin of error in this one. Okay, any questions?
Nope.
Okay.
I have a quick one on the square root of 120. Do you have to put parentheses on that? Because I know my calculator doesn't generate the parentheses. Do I have to add that?
No, you don't, because there's only one number.
Okay.
Yeah. So that's why sometimes you kind of, go ahead and test your calculator, trying to get familiar with that, right? So on the test, you make sure you will do that right. So for this, since this is only one number, so if it doesn't automatically get a parenthesis, you don't have to add it.
Okay. Thank you.
Right. Okay, second one, very similar, except this one, C is 0.95. Okay. All right. So when actually there's a little bit margin of error. All right, we can go ahead and do the second one right here, which is very similar to the first one, just change a little bit. So remember, C is in the middle. Okay, the confidence interval C is in the middle, 0.95. So how do we find these two tail? Okay, this tail, you can use 1 minus C divided by 2. Okay, 1 minus C is 0.95 divided by 2. Look at it. This will be 0.05 divided by 2, so that's 0.025. Okay, and this G sub C will be negative. This G sub C will be positive. So this time you will only just need to use 0.025 to do this one. And I go to second vars using, second vars, and then you use the inverse norm, right? And then I just type a 0.025, and that will giving you negative 1.96 in this case. Okay, the other one is positive 1.96. And then we use the same formula as we have earlier to do the calculation. We still want to find the margin of error, all right? And then that's G sub C times sigma divided by square root of N. And then sigma here is 677, N here is 40, right? And then since this one is, the good thing is this is integer, so we just put it in the calculator and run to the integer. All right, whatever the question format asks, we use that for the question format in here, and that is 40. Okay, so since this is want you to run to integer, so I have a 209.8, right? 209, let's write it down, 209.8. And then if I run to integer, this will run up because the file above will run up. So that would be 210. So that would be this one right here, will be 210 if we run to the integer. Okay? Any questions?
Oh.
All right, okay. So number 3, random sample of the 40 students has a mean annual earning of $3,120. Assume the population standard deviation is 677. Construct a confidence interval for this population mean. If C is 0.95. Okay, so what is the confidence interval for the population mean? Confidence interval, we have a mu is between x bar minus e and x bar plus e. That is called a confidence interval. So this is x bar. The mean earning is 3120. Okay, 3120. And then E here, if you look at the E here, actually this is the same as the previous one. N is 40, right? And then we have a C is 0.95. Look at C is 0.95, N is 40. And then we have a standard deviation, sigma is 677. So this one is just kind of a continue from the last question. So since I already found the E, look at that, I already found the E here is 210. So I will just need to minus and plus 210 in here. And this will giving you 29103330. So my confidence interval, you write down the smaller number on the left, write down the large number on the right. Okay, and that way we can choose the confidence interval, or you can just write down, if they ask you to write down, that will be the confidence interval in here. Okay, any questions? So if you know how to do these 3 questions, that is pretty much all for the chapter 6. It might change a little bit, but basically this is pretty much 90% of the concept for chapter 3 in here. Okay. I will also want to show you how to use a calculator to find a confidence interval. Yes, you can use a calculator to find this whole thing. If it didn't ask you to find a margin of error, if we only ask you to find a confidence interval, I can use the whole calculator to find this one. And that will make this calculation even easier. All right. So go to state, and then we're going to use a test. So this last 2 chapters, we're going to use the test button quite a bit. All right. Next, the last chapter, we're going to have a G and T test. For this chapter, we're going to have an interval, G and T interval in here. All right. And we know we're going to use the G interval, and I'll tell you why later on. Okay. Because we also have one called T interval, which is very similar, but this one is G interval. The reason is G interval because it's giving you the population standard deviation, or giving you the sigma, and that you will use the G interval. Okay, and then since we giving you the mean here, so I'm going to just using the mean. Okay, and I type the sigma here is 677, X bar here is 3120. N is 40, right? And then the confidence level is 0.95. And then I just hit calculate. All right, this whole thing is my Z interval in here, or the confidence interval for the Z. If I run to the integer, I got exactly the same answer. 2910, and then this is run to integer, this will run up, so you will 3330. All right, so this calculation make the whole thing a lot easier, okay? But I just go through step by step using the formula in here. But not every question you're gonna be able to use a calculator, right? Because we have some question we're gonna ask you margin of error. Once you find out the margin of error, the confidence interval is almost done. You're just using the sample bin plus the margin of error and minus the margin of error on each side, and that's it. Okay. All right. So this one is a random sample of the 60 computer. The mean cost is 150. Okay, assume the population standard deviation is 36 because it said population standard deviation. So we know sigma is 36. Based on this criteria, we know this is Z interval. Okay, not a T interval, which we're gonna calculate later. So this one is a Z interval, and then we have N here is 60, right? X bar here is 150, okay? And then we're gonna go ahead and calculate this one. The first one is 99% confidence interval. The second one is 95% confidence interval. And then we're gonna go ahead and compare these two, okay? And I'm gonna give you a little bit, okay, let's go ahead and find out A, if I have a C equal to 99% confidence interval, which is 0.99, right? And if I go ahead and use the calculator, which is really quick, go to stat, test, and then I'm using the number 7, C interval, right? And then I just change this one into 36. X bar is 150. N is 60, and then this is 0.99. I just go ahead and calculate in here. If I run to integer, this will be 138, this will be 162. Okay, so that is for 99%. If I change it to 95% or 0.95, let's see what happened in here. Everything else is the same except the confidence level. I change it into 0.95. And then this one, it will become 141 to 159. Okay, so what's difference in here? I drop a little bit picture this in here. 99% confidence interval, we have a 138 to 162, right? And then if you have a 95% confidence interval, I have a 141 to 59 in here. So what is the effect of the confidence interval with the interval? The confidence. We can see like if you want to be very confident, like I said, 99% of the time, your interval, guess what? Your interval gonna be bigger, okay? This interval gonna be larger. All right, so I kind of compare you with your test score, right? If you want to be 99% confident, what happened? Well, you better have a bigger score range. Like I said, you have a 99% confidence that you're gonna test the score from 60 to 95, right? If I giving you, if I say, how about what is the chance, or what is the confidence that you're gonna test between 95 to 96? What do you think? Well, your confidence probably not really that high. You probably won't be 99%, right? So some people say maybe I will only have 80% confident that I'm going to test 95 to 99 to 96 because this interval is so small. Okay, I'm not sure if I'm gonna test exactly like that. All right. So if we're giving you a big interval, your confidence level will increase, right? And if I ask another person, say how confident you're gonna test between 70 to 90, well, the 70 to 90 is a smaller interval than 60 to 95. So some people say I might not have 99%, I might just have a 90% of the confidence. So what do you think? Does that make sense to you? If I use the test score compared to the interval in here.
Do you mean you just want us to understand that the bigger the interval, the higher the confident number or confidence
Right,
number?
right. Because if I giving you the test score from 0 to 100, what do you think? Well, we never give anyone penalty. So if you didn't, even a multiple choice, we didn't give anyone penalty. So your lowest test score, you're gonna be 0, right? And then your higher test score will be 100. So that means I'm 100% confident that the test score will be between 0 to 100 because that's all the range we have, right? So my confidence level is very high. But if I ask you, say how confident that you're gonna be from 90 to 100? Well, will you be 100%? Can you tell me that you're gonna be 100%? You're gonna be testing between 90 to 100? Probably not, right? Probably you don't have 100% confidence. You probably say I'm maybe 90% confident. So your confidence level will decrease between a smaller interval. All right. If you want to have very confident, you better give yourself a lot of range, right? You know, this range is much bigger that way. Okay. All right. So that is just want to explain like the changing the interval in here, the effect, you know, with the effect of the confidence interval. That means if you want to have a very high confidence interval, if you want to have a very high confidence level, your interval must be larger. All right. Otherwise, it will not be able to achieve that. Okay, number 5. This one is giving you a little bit of sample size. Okay. A nurse at a local hospital is interested in establishing a birth rate of infants. How large the sample must be selected if she desires to be 95% confident that the true mean is within 3 ounces of the sample mean? All right, so this actually, we have a E is equal to G sub C times sigma over square root of N, right? If we're giving you the N, we can find the margin of the error. And then this formula, we can solve for N, okay? And how do you solve for N? You multiply both sides by N, and then get rid of E in here. So I have an N will be square root of N will be G sub C times sigma over E, right? You solve for N. So in order to get N out from the square root, I will square both sides. So that way we have N is equal to G sub C times sigma over E, but don't forget you need a square. So that is the sample size formula. The reason I'm giving you this one, I just want to let you know that this formula and the margin of error, these two formula actually is from the same formula. Okay, and if you're giving you the N, you can find the E. If we're giving you the E, you can estimate the N. All right, and the good news is our formula sheet do solve this N for you in the formula. So if you look at this one right here, look at it. We do have a formula sheet. So that's why I like this book, because everything is already given to you. Some of the book, they don't solve this formula for you, okay? All right, so this one, you have an N is already solved for you. And we just need to plug everything in. One thing is when we have a C is equal to 95%, we have a G sub C here is 1.96. Okay, if you do not know this one right here, you have this confidence interval G sub C right here. If one of these 4 commonly used confidence interval, you can use the G sub C directly from the table. You don't have to find on your own. Okay, the reason I showed you earlier how to find a G sub C on your own, because sometimes we don't have a confidence label is in here. But if these 4 are the most commonly used confidence label. If you have one of these, like this one is at 95%, right? 95%, my G sub C will be 1.96, so I can use it directly. All right. And if it's not one of those 4 I showed you earlier, how do you find them, right? You just drop the C in the middle and find the tail, and you will get it. And this, the standard deviation of the birth weight is known to be 6 ounces, so this will be 6. Okay, and then the error within 3 ounces. All right, so we will need to don't forget, you will need to do the square. Okay, so when we do the calculation right here, you need a parenthesis. Okay, you need a parenthesis, and don't forget the square. So we have a 15.3664, but remember the sample size, we always use the integer, and then this is always round up. Okay, always round up to the next integer. So this one is called spatial rounding. Okay, this is spatial rounding, and it's always round up. So regardless, even if you have a 15.06, you still need to round to 16. All right. Otherwise, if you choose 15, that will be the incorrect one. Correct answer should be 16 in here. Because in order to make sure we got enough sample size, we always need to round up. Unless you have a 15 exactly without any decimal point. Okay, otherwise, as long as you have 15.001, you still need to round to 16. So this one is not a regular rounding. Okay, it's not like a 4 below, you round down, 5 above, you round up. Okay, this is called spatial rounding, and you always need to round up for that. Because sometimes you might do the calculation right, and then you choose the wrong answer. All right. Any questions? Okay, so that is for that one. For number 6, we're gonna have a T interval. Okay, and the T interval is also called a student interval because it was discovered by a graduate student. All right, so this one is very similar, but when do we use the T interval, which we usually have a smaller sample size, right? The one we use the T interval usually is a smaller sample size, okay, smaller sample size. And then sigma is unknown. So sigma usually is the population standard deviation. This one is not given to you, but usually is giving X. All right, so what's different of the X and sigma? Sigma is the population standard deviation. X is the sample standard deviation. Okay, so that is the main difference of these two when you use a G or T interval. This one is very obvious. It asks to find a critical value for the T sub C. Okay, the T sub C, if you look at the table, it using called the degree of the freedom. As I said earlier, this chapter you have a lot of concept. The degree of the freedom here is n-1. Okay, and let me show you this table very quick. So this is table 4 is the G table, And then table 5 is a T distribution. So we will look at the degree DF. We're using the DF for the degree of the freedom is 15, right? And then we look at the confidence C is 0.95. So look at the level of the confidence 0.95, 0.95 right here. All right, and then this is 15. So we have this one is 2.131. Okay, so this table is not a bad to read. You just have to be careful. So T sub C here is 2.131. All right, so that is this one right here. Number 7, construct the indicate confidence interval for the population mean mu using the T distribution. So this one is already giving set T distribution. The reason you need to use T distribution because it's giving you X in here. Sigma is not giving. So giving you X, sample standard deviation. That is the key here that you need to use the T distribution, right? This interval is also using X bar minus E and then X bar plus E. So it's very similar to the Z interval. My X bar here is 645, right? Okay, so I will just need to go to find the E and then plus minus in here. So how much is the E? Well, E here is T sub C times X over square root of N, all right, for the T interval in here. And then we already found out this one right here. N here is 16, so my DF will be 15, right? And then C is 0.95, so it's the same as this one right here, okay? So I using the T sub C is 2.131 times X here is 31, divided by square root of N is 16, and then we know square root of 16 is 4, right? So if you go to calculate this whole thing, this is 16.5. So I will just need to plus and minus 16.5, and I will get an interval. I will get an interval in here. This is 628.5. This is 61.5. So that way we got an answer in here. We got an answer. Okay. Another thing here is you can also use the calculator to find this whole T interval, just like I showed you earlier. Okay, so I showing you, go to stat, test, and then we're gonna use number 8. Okay, we have a T interval in here. Look at it, we have a T interval. And then we just input X bar here is 645. X here is 31. N here is 16, and then the confidence level is 0.95. And then we can just go ahead and hit calculate. And then if I run to 1 decimal point, I got exactly the same answer here. Look at it. So there's one shortcut in this chapter that you can find an interval directly from the calculator. Yes, that will help quite a bit of the calculation. Okay, any questions? All right, next one right here is construct a 90% confidence interval for the population mean mu. Assume the population has a normal distribution. A sample of the 15 randomly selected students has a GPA grade point average of 2.86 with a standard deviation as 0.78. Okay, the challenging here is not a calculation because I can put this whole thing into calculator. The challenging here is trying to identify, is this a Z or T interval? Is Z or T interval, and why? Okay, that will be the most important one, because if 4 answers, 3 of them are incorrect, right? If you use a wrong interval, you might also have one match incorrect answer here as well. All right, the key is Z or T interval before we even start.
Is it Z?
Tell me how you say is why is Z?
Because it asks to construct a 90% confidence interval for the population mean, and it gives you the T stuff.
No. The T interval is also can have a confidence. The T interval is also want to find a population mean interval. So the fourth sentence, it doesn't telling you actually from here, everything to that up to here, assume the population has a normal distribution. Up to here, it didn't telling you, you cannot identify this G or T up to here. The key here is the last sentence, this one. This one is the key, you identify G or T. A sample of the 15 randomly selected students has a grade point average of 2.86 with a standard deviation as 0.78. This is the sentence you identify G or T. Okay, I heard that some people have a chat.
It was just me. It was just, I was just like, no.
Okay, so a G or T interval. All right, so I'm gonna telling you here, this one actually is a T interval. That's why I say it's very tricky. Okay, two ways you can kind of help you to identify is T interval. As I said earlier, T interval, usually the sample size is smaller. N usually is smaller, usually is less than 30. So if we look at this one right here, we have N is 15, yeah, it's less than 30, but this is still not the key breaker. The key breaker here is this standard deviation. Is okay. What is this standard deviation from? What is this from? Is this from the population, from the entire population, or from just from 15 students?
Population?
Where did it say the population?
Oh, I'm not sure. I was guessing.
Yeah, right. This is kind of, that's why I said this is a little bit tricky, okay? A sample, so this is kind of, now you have to break down in your English sentence structure here. A sample of the 15 students, this 15 students is not an entire college or entire class, but it's just a what? A sample, is that right? Do you agree? This 15 students is just a sample. Because that's what a question to you, right? A sample of the 15 randomly selected students has a GPA of 2.86 with standard deviation is 0.78. So this standard deviation is from the sample of the 15 students. It's not from the entire population. It didn't say this is from entire population. So that is the key thing. So we giving you the X here is 0.78. Sigma is unknown. Sigma is unknown, or sigma is not given. Unknown is, that means it's not given in here. Okay? When sigma is unknown, yeah,
so
this
is
is a sample.
S and sigma the same thing, but for sample and population, that's
right,
the letters are different? Okay.
Yes. Yes, that is the very important one. And I'm glad you are here. So, sample standard deviation is giving you using a small x. Okay, and that is for the T interval. All right, if you go to look at our previous sample here, look at it. This is T telling you using T distribution and giving you the X, right? Not a sigma. Okay, and then if you go back to look at this one right here, this one giving you, this is a sigma, not an X. Is that right? So that's why I know this one is a G interval, because it's giving you the sigma here. All right. So if you didn't know the difference of the sigma and the little x, now you need to know that. All right. So this one telling you, look at it, this is telling you population standard deviation. Is in the population right here, population standard deviation. Okay, that's why it's a Z interval. All right, and same thing, this one is the population standard deviation right here. All right, so that's why it's a Z interval in here. This one right here, giving you this one is little x, so that's why it's T interval. Okay, and that's why this kind of a question, it didn't giving you x or sigma, but we have to go to read between the words, between the lines in here. And then we understand this standard deviation actually is from the sample, not from the population. So therefore, it's a T interval. Okay. All right. Once we know the T interval, I can just calculation. Actually, as I keep saying earlier, concept is the most important one. Calculation, I can if I don't want to calculate by hand, I can do it in the calculator. All right. So sample bin here, average is 2.86. Standard deviation is 0.78. N here is 15. Confidence level is 0.9. I can just go ahead and hit calculate. And I have a round to 2 decimal points, so this is round up. Third digit is 5, you round up. This is regular rounding, right? So I have 2.51 to 3.21. So I have the answer right here already. Okay, you can either just mark your answer or you just write down your answer. That is how you calculate in here. So the key thing here is knowing this one is a T interval. Very, very important. Okay. All right. Number 9. Again, let's look at this one is a G or T interval. Construct 19% confidence interval for the population mean. So we know this is finding the interval for the mean. Assume the population has a normal distribution, so nothing specific here. Last sentence is the key. In a recent study of the 22 8th graders, the mean number of the hours per week that watched television was 19.6 with a standard deviation as 5.8. So what is this standard deviation from?
The sample.
Yes, that is very good. It's from the recent study of the 22 8th graders, and we know there's a lot of 8th graders out there. So we know this should be a sample standard deviation. It's X, not a sigma, okay, not a sigma. So we know this is a T interval, okay? And then we have an N here is 22, X here is 5.8, C here is 0.9, and the X bar here is 19.6, and then we can put this whole thing into the calculator. You know, like as I said earlier, I can, if I don't want to calculate by hand, I can do that in a calculator, which is 19.6, and then that is 5.8. N is 22, so less than 30. So that is giving you another key here. And then round to 2 decimal points, so we have a 17.47 and then 21.73 because this you need to round up. All right. So look at this one. Calculation is quite straightforward if you use a calculator, right? But the concept, you just have to be very careful. All right. Okay, so that is pretty much about chapter 6. Number 10 is this is the population proportion. Okay, we actually skip the section for the 6.45. So the proportion actually just using the number of the X over N, right? A survey of 100 fatal accidents showing 16 were involved in alcohol. So we're just using find the point estimate of P. So the population proportion is just using X over N. So about 16% of the accidents were involved in alcohol. that kind of thing. So that is the easy one. We didn't really ask you to find a confidence interval for that. So that should be an easy one in here. Okay, move on to the chapter 7, which is another new concept here, and more concept in chapter 7. So again, calculation in chapter 7 is also pretty straightforward, and you also have a calculator app for that. But concept, as I keep saying earlier, concept is very important because especially chapter 7, you got more concept than chapter 6. So the new concept here, you basically have to be very careful. All right. Look at 14. Statement represent a claim. So what is a claim here? Claim actually is a statement. Okay, from the question. Right is the complement, and state which is H sub naught and which is H sub A. So you will know. I don't know how many you get to the chapter 7. Did anyone of you start at chapter 7?
Not me.
Okay, if not, this will be totally new, brand new. Okay, so chapter 7 is the hypothesis test. And then we have 2 different type of hypothesis. One is called a non-hypothesis. One is called an alternative hypothesis. Okay, and the non-hypothesis is always include 0. Non is, that means 0 difference. Okay, non is 0 difference. So you always have an equal sign. Okay, if I say A and 90 are the same, they are equal. So that means A, if you got an overall grade is 90, you got an A, right? So A is equal to 90. And that means the non is always include the equal sign. Okay, that is the key here. And we have 3 pairs. So what are those 3 pairs? This is the alternative. So if a mu equal to 0, this will be not equal to 0. That's 1 pair, right? Okay. And another pair for the non and alternative here is if mu is less than or equal to, like I said, a number A, the alternative one will be kind of complementary. We said a complementary, so this will be greater than. All right, so that's the second pair. And then we have a third pair here is this one is greater than or equal to A, and then this one will be less than A. So that is complementary in here. And then if we look at this one right here, this is called two-tail because you have a not equal to, when I said not equal to A. Okay, not equal to can be less than or greater than. So that's called a two-tail. Okay, so this is called two-tail test. This is greater than, so greater than is only 1 tail. And this 1 tail we call the right tail because we're gonna test this on the right hand side. This pair is less than is on the left hand side. So we're gonna call this is left tail test. These both are called 1 tail, right? Because you either to the left or to the right. This is only one side of the tail, so that's called 1 tail. This one, the reason called 2 tails because you have a left tail and also have a right tail. Okay, so I just explained these 3 pairs. Now, if we look at this one right here, this is a statement, right? So this is a statement. This P is less than or equal to 0.93. Since this one has an equal sign, so it must go to the non-hypothesis. Okay, so this one must be a non-hypothesis. And my alternative one here will be P will be greater than 0.93. So we're gonna go to look at which one match. If you look at this one right here, this is the only one match, right? P is less than or equal to 0.93, and this is also called a claim because this telling you this represented a claim or a statement from the question. And then alternative one should be greater than because you have a less than or equal to alternative one must be greater than. So that will be kind of similar to this group here, similar to this group. All right, any questions? As I mentioned, this chapter gonna have a lot of concept, right? Calculation, you have a, but concept even more. All right, let me see. Any questions?
That was me. Sorry, my kids are just talking in the background. I did not understand that at all.
Okay. The reason you don't
I get the charts
because
matching with that, like the two tail versus the right tail versus the left tail, but I don't get why you chose the answer you did.
okay, because this is giving, right?
Right.
This is from the question, and the question you have this one here is have an equal sign. Everything with an equal sign must go to the non-hypothesis.
Okay, got it.
Yeah, and then the other one is just the complementary. So what does a complementary mean? Look at this one right here. If you have a less than or equal to, complementary one will be greater than. If you have a greater than or equal to, complementary will be just less than. You cannot be the same as the previous one. So it's called a complementary. Kind of like an opposite, but in math, we don't call it opposite because it's still a positive number. We call it a complementary. So this inequality just go to the different direction. All right, so that's why I said this chapter, I do encourage everyone read chapter 7 because especially 7.1 introduce a lot of concept, okay? In my 100% lecture class, we spend the entire class to explain the 7.1. All right, so it's a very, very important one concept here. So you will need to spend a little bit more time. That's why I said if you didn't finish you didn't start at chapter 6 right now, you're gonna be very challenging because we only have 1 week left, right? And then you have to have an entire chapter in here. Okay, so look at number 15. The alternative hypothesis is given with this graph, state the non-hypothesis. All right, this is the alternative one. So alternative one, look at the alternative one given to you. You're gonna need to be able to write down the non-hypothesis. So the non-hypothesis, we said earlier, is the complementary. So if I look at these three, group. Group 1, we're gonna call this group 1, group 2, group 3. The good news is we only have 3 groups in all the hypotheses.
Mm-hmm.
When do you choose?
The first one?
Yeah, the first one, that's exactly right, because we have this is not equal to. So the complementary for this one will be equal to. All right, so that is this one right here. So we're gonna choose this one. So the correct answer will be just B, right? We have this non-hypothesis must be equal to 5. Okay, not this one, not this one don't even have an equal sign. So this is absolutely wrong. Okay, but not this one either, because the non-hypothesis must be complementary with this one. All right, so that is equal to 5. So that is the right one. All right, I hope even you attend the class, you might also want to come back later on, review this chapter video again, because it will giving you more clarity later on after you do some practice on your own and then read the textbook as well. Okay, but I still just only want to go through, and hopefully you can understand as much as possible that way. Okay, number 16, a brewery claims that the mean amount of the beer in a bottle is at least 12 ounces. So what does at least mean? At least, that means it's greater than or equal to. Mean is greater than or equal to. When someone say at least, that means greater than or equal to in math, right? Determine whether the hypothesis for this claim is a left tail, right tail, or two tail. Well, we will need to write down the non-hypothesis and alternative one in order to identify its left, right, or two tail. So this one has a greater than or equal to, so it must go to the non-hypothesis because it has an equal sign. So my alternative one, the complementary, will be less than. All right. So when we look at the left tail, right tail, or two tail, we look at the alternative one. So since this one is less than, so what does less than mean? Less than is only on the left hand side. So this is a left tail test. is a left tail test in here. Okay, does that make sense? When you look at the left tail or right tail, you will need to look at the alternative one. Now look at the norm. That is the key thing. So every question in chapter 7, you always need to have this we call it step 1. Write down the norm and alternative hypothesis, because we're gonna use a lot compared to make a conclusion later on for this chapter. Okay. All right. So number 8, the p-value for the hypothesis test is 0.066. Do you reject or fail to reject the non-hypothesis when the significant level alpha is 0.05? Okay. We have a, okay, now it's kind of hard to explain to you if you haven't studied this one. All right, let me go ahead and jump to this one right here. I posted this page of the chart on my TC, and I do allow you to use this one, especially at the beginning when you do the homework. You might want to print out this page, because this is the conclusion you will have to make the final decision. Are you gonna reject or do not reject the non-hypothesis? And even after you reject or do not reject the non-hypothesis, what does that mean? So this page, we are giving you the whole information in here, okay? And I am going to giving you, let me see if I can open one page of this section very quick, because it is a little bit challenging for section 7.1, okay? This is known and alternative hypothesis. I introduced this 3 group earlier in here. And then we have okay, I just want to show you a little bit procedure. Okay, so this is the page in here. Let me go ahead and make a copy of this page into here. All right, so making a decision in here is if you have a p-value compared to the alpha value. If p is less than or equal to alpha, you will reject a non-hypothesis. And p is the probability. Alpha is the significant level. If p is greater than alpha, then you fail to reject a non-hypothesis. Okay, so that is the very important one in this chapter. So if we have a p is 0.066, my alpha here is 0.05, right? What happened in here? Well, my p actually, if you compare this decimal point, my p is greater than alpha. So what happened in here? That's why in this chapter, you have to remember this sentence very well. This is the condition. When p is less than or equal to alpha, you reject a non-hypothesis. When p is greater than alpha, you fail to reject the non-hypothesis. What does fail to reject mean? Sometimes we just say do not reject the non-hypothesis. It's the same thing. Fail to reject or do not reject the non-hypothesis is the same thing. Okay, so we have a p is greater than alpha. Of course, we will say fail to reject a non-hypothesis in here. Fail to reject. Okay, so that is based on this conclusion, and you do have a concept in here. That's how you're making a decision. Is based on this criteria in here. Okay, number 19, use the p-value for the hypothesis with the standard test Z. Decide whether to reject this non-hypothesis for the level of the significant alpha or not. Okay, so I have a Z test in here because I'm giving you this one right here, right? And this is telling you is a left tail test. So left tail test, that means my area is entirely on the left hand side. And my G here is negative 1.83. And what is my p-value? P-value is the area. Okay, so my p-value here, I can go to read the table, right? Giving you the z-score, you can read the table in here. So I am going to read my table, z-table, okay? And this one is negative 1.83, so let's look at negative 1.8 right here. Negative 1.83 will be right here. So that will give you 0.0336. Okay. All right. So p-value here is 0.0366. This is from table 4. Okay, we read the table 4, giving you the z-score. You will be able to read the p-value. And then I compare the p-value with my alpha. Okay, alpha here is 0.05. So what do you think? This time, my p-value is what? Less than alpha. Okay, less than alpha. So less than alpha here is reject the non-hypothesis. So that is this one right here. This one is easy because this is the only correct p-value in here, right? So you read this p-value from the table, and then let's reject the non-hypothesis in here. All right, number 20, find the critical value and the reject region. This one actually is reading the kind of, okay, critical value. So this telling you is a two-tail test. So two-tail test, that means I will have a left tail, I will have a left tail, I will also have a right tail. Okay, and the alpha is 0.01, but since I have a two tails, so I have to split into a half. So this will be half of the alpha, this will be half of the alpha. So this area will be 0.005. This is also 0.005. But as I said earlier, with z-score, this will be negative, this side will be positive, and since the bell curve is symmetric, so these two numbers will be the same, right? So if I want to read my z-score, I will just reading my table backward, or you can use the calculator. Second bus, this is reading table backward. Okay, type 0.005. And that will giving you the number here. We have a 3 decimal points, so we have a negative 2.576 actually. But you know, since if we read it from the table is not as accurate as calculator. So that is the closest answer in here. Okay. All right. So that is how you find a critical value in here. And this is also called a rejection region, okay? All right, I'll give you one complete answer in here. Test the claim that the population mean mu at the level of the significant alpha. Assume the population is normally distributed, okay? And this one is giving you the sigma. Now you recognize the sigma in here. As long as it's giving you the sigma, this will be called a t-test. If we're giving you the x, this will be a t-test. So in chapter 7, we also have two different type of hypothesis. One is a g-test, one is t-test in here, okay? And giving you the sigma, so that is a g-test in here. So the good news is g-test, we have a g-score is x bar minus mu over sigma divided by square root of n. This is the only formula for the g-test. And the good news is we did calculate this formula before. So the calculation is nothing new, but the concept is brand new, okay? In order to say fail or reject a non-hypothesis, we need to write down the non and alternative hypothesis for this question. So we have a mu not equal to 35. So this should go into the alternative because it didn't have a equal sign. So my non here will be equal to 35. It's a complementary. Giving you one of these, you should be able to write the other one. Okay, so that is this one right here. So we also know this will be a two-tail test because this is not equal to. So we're gonna have a two-tail. So two-tail, it will be one on the left, one on the right in here. Okay, and we can go ahead and find a p-value. So z here is x bar minus mu over sigma divided by square root of n. We can put this whole thing in. X bar here is 34.1, mu here is 35, sigma is 2.7, n here is 35. Okay, if you put this one into calculation, it's 1.97. So we have a negative 1.97 in here, but since this is two-tail test, so this will be half of the p in here. So my p value, half of the p, I can go to read a table from here. If I read a negative 1.97 from the table, negative 1.97. Okay, so that's 0.0244. All right, so my entire P will be, you add the two areas together, multiply this one by 2, right? Multiply this by 2, this will be A, and then that's 4. So 0.0488. Compared to my alpha here is 0.05. So P is less than alpha, okay? So what happens when P is less than alpha? We reject the non-hypothesis. As I mentioned earlier, we have this page of the formula. When P is less than alpha, okay? When P is less than alpha, we reject the non-hypothesis. So that is the conclusion in here. All right, and what does this whole thing mean? When you reject a non-hypothesis, what does that mean in here? Well, if we also look at this page in here, my norm here, my claim here is in a alternative one. So my claim here is in an alternative, and I reject a non-hypothesis, so I have to make this conclusion. Okay, I have this conclusion in here because we have a claim is in an alternative one, and we just reject a non-hypothesis. So this is your conclusion. The conclusion here is there's enough evidence to support a claim. All right, so that is how you make this conclusion in here. So answer B will be the right one. There's enough evidence at 5% level of the significance to support a claim because we just reject a non-hypothesis. All right, I know there's a lot of concept in between in here, but if you want to find this one, I can also show you there's calculator that you can use in here. Okay, so let me show you G test. Go to state test, and then using the G test in here. Okay, and then we input a mu here is 35, sigma is 2.7, x bar here is 34.1, and then n here is 35. And then we also have to input the tail. So we tail here is two-tail. So I will put a two-tail test. And then go ahead and hit calculation. So we have a G-score right here. Look at that. I just have a G-score 1.97. And then I have a I also have a p-value. Look at it. This whole thing giving you very similar in here. Okay, similar to the one we just calculate by the formula. Didn't let me paste. Anyhow, it won't let me paste that one. Okay, so but you can tell like this calculation is giving you the p-value in here. Okay, this p-value actually is even more accurate, but we also know it's less than alpha. All right, so that is you can also use the calculator to find a G-score and also find a p-value directly from there. Okay. All right, so I will do just one more question for this one in here. There's another one is called a t-test. Okay, we're gonna go ahead and look at a little bit called a t-test in here. The reason is a t-test because is x is given. When x is given and sigma is unknown. All right, so the good news is this concept is the same as the previous chapter. When x is given in the previous chapter, you using the t interval. In this chapter, you use the t-test. Okay, so those two are the same thing. And how do I find a critical value for the rejection region for the t-test if alpha equal to 0.1, n is 35? Remember t-table using the df. So df is n minus 1. So this is 35 minus 1, which is 34. And then we have a right tail test. So when you go to look at the table, let's see. All right, let's go ahead and open the table very quick. Oh, I have a table right here already. Okay, so t-table, we have a df is 34, and then alpha is 0.1, and then that is right tail, right? So right tail is one tail, so we're gonna look at the one tail in here. And one tail alpha is 0.1, so that is the false one right here. So either left tail or right tail, they both are called one tail. But the left tail, you will have to add a negative on your own because this table is only giving you the positive. So when you have a left tail, you will have to add a negative. When you have a right tail, it's only positive. So df is 34, right? So we're gonna go down here and then look at the 34. So that will give you 1.307. So that is the critical value in here. Okay. All right. So that is right tail test. So right tail test, and then the t here is 1.307, and this is positive, right? Because alpha is 0.1, and then df is 34 right here. Okay, so that is the critical value for this question. If I have a t-test, is pretty much similar. Okay.
The answer on that question was B.
For 25.
Yes, I'm asking.
Yes. Yeah, that is B in here. Yeah, the right tail, so it's greater than. All right, one more question in here. Find a standard test for the t for n is 10, x bar is 16.5. Look at it. This is t because it's giving you the x, right? And if mu is if non-hypotenuse greater than or equal to 17.4, my alternative one, mu will be less than 17.4, okay? And this one, you just need to find a t value. It didn't ask you anything else, just need a t value. So t value is x bar minus mu over x divided by square root of n. It's very similar to the g-score, but using the x instead of sigma, okay? And that's 16.5 minus mu here is 17.4. X here is 1.3, N here is 10. So you can put this one in a regular calculator, or if you don't want to put it, there's another interface for this one. Okay, you can put it in a regular calculator just like this, 16. Okay, make sure I close all the parentheses I have. All right, so this is negative 2.189. Okay, that is one way you use the formula and then you do the calculator. Another way to find this one right here, you can go to stat, test, and then we're using the t-test in here, okay? And we input the same information. Mu is 17.4, x bar is 16.5, x here is 1.3, n here is 10, okay? And then we say this is a left tail test because I have a less than. All right, the good news is when you do this one right here, it giving you both number, it giving you the t value, it also giving you the p value, which is the additional one. So you don't have to read the table again. So the t here is negative 2.189. Look at it, we just do the same thing. So if you go to find from here, it also giving you the t, same t value in here, which you don't have to input this whole thing again, you know, using the subtraction, division, you know, those parentheses. And the good news is this is also giving you the p value. So my p here is 0.028. So that's the additional information, which is very important if we need it to identify we're gonna reject or do not reject a null hypothesis, which I already have a p value. I can just compare to my alpha. Okay, and then this p is less than alpha. Look at the alpha is 0.05. So my p value actually is less than alpha. So less than alpha, that means I reject a null hypothesis. Okay, of course, this if you just only need to answer this question, you don't need a p value. You don't have to answer this much, but you just need a t value. But I just giving you more information just in case you know other questions will need this information. Okay. All right. So that will conclude all the chapter 7. As you can tell, there's a lot of new concept in chapter 7. So make sure you go through the concept first, and then maybe you come back to review the question a little bit more after you know read the textbook and you know understand some more concept, and it will make much more sense later on. But I already shown you all the key concept, key calculation, include the calculator as well. Okay. All right. Any questions?
No, thank you.
All right. So that is all for tonight.